How's it going, guys? We are doing why scientists should be educated in rhetoric. So, first of all, evidence is useful, but what can you do when people don't believe facts? The world has become increasingly set in its ways. In 1975, researchers at Stanford invited a group of undergraduates to take part in a study about suicide. They were presented with pairs of suicide notes. In each pair, one note had been composed by a random individual, the other by a person who had later taken his or her own life. The students were then asked to distinguish between the real notes and the fake ones. Some students discovered that they had a knack for the task. Out of 25 pairs of notes, they correctly identified the real one 24 times. Others discovered that they weren't very good at it. They identified the real note in only 10 or so of the instances. As usually the case with psychological studies, the whole thing was a setup. Though half the notes were indeed real and genuine, they'd been obtained from the LA County Coroner's Office, and the scores were made up. The students who'd been told they were almost always right were, on average, no more discerning than the ones who had been told that they were mostly wrong, so it was about the same. And in the second phase of the study, the deception was revealed to them. The students were told that the real point of this experiment was to gauge their responses into thinking that they were right or wrong. Finally, the students were asked to estimate how many suicide notes they had actually categorized correctly and how many they thought an average student would get right. At this point, something strange happened. The students in the high score group said that they had thought that in fact they had done well, significantly better than the average student, even though as they had just been told by the researchers they had zero grounds for believing it. On the other side, those who had been assigned to the low score group said that they thought they had done significantly worse than the average student, a conclusion that was equally, that didn't make any sense. So once formed that the researchers had concluded, the impressions were remarkably persistent throughout the two groups. And this shows that no matter what evidence you can throw at somebody or an argument, they are more likely to dig their heels in.
So the fact that many of us don't believe in science, public opinion polls consistently show that significant proportions of the American people don't believe the climate is warming due to human activities, don't think there's evolution by natural selection, and are persuaded by the safety of vaccines. So why should we believe science? So pretty much what I'm saying is scientists don't like talking about the science as a matter of belief. In fact, they would contrast science with faith, and they would say belief is the domain of faith. So what that means is pretty much scientists claim that they are saying that scientific claims are a leap of faith. So if you think about it, geologists can't tell whether a vaccine is safe. Most chemists aren't experts in evolution theory, and a doctor wouldn't be able to tell you. A doctor is not certain to tell you that tobacco causes cancer or not. So even if scientists themselves have to make a leap of faith outside their own fields, why do they accept the claim of other scientists? So why should we believe those claims? So what I'm arguing is, yes, we should, not for the reason of most of us think, should believe scientists, but most of us were taught in school that we should believe science is everything is true because of the scientific method. We were taught that scientists follow a method that guarantees the truth of their claims. It's quite hard to persuade everyone that the science is completely true, but what I'm saying is that a lot of major changes in scientific thinking are relatively rare in the history of science. At the end of the day, what science is, it's scientific knowledge through the consensus of the scientific experts who, through the process of organized scrutiny, collective scrutiny, have judged the evidence and come to a conclusion about it. It's either a yay or nay. So what I'm saying is that scientific knowledge as a consensus comes through a bunch of experts looking at what they studied. So, and those experts are obviously a lot of men and women with PhDs.
Scientists need to be fluent in the art of rhetoric because of the things that was already said by my partners, but how they can do that without knowing how to apply that rhetoric. I'm going to explain 3 simple modes of persuasion for how people with expertise in the field of science can use some basic rhetorical skills to be educated in rhetoric and use it in their everyday lives to give their research and findings a more powerful impact for the people not necessarily willing to listen to these findings. I'm going to read a quote from Aristotle that explains these 3 simple ways, and it goes as this. Of the modes of persuasion furnished by the spoken word, there are 3 kinds. The first kind depends on the personal character of the speaker, ethos. The second on putting the audience into a certain frame of mind, which is pathos. And the third on proof, or apparent proof, provided by the words of the speech itself, logos. Persuasion is achieved by the speaker's personal character when the speech is so spoken as to make us think him credible. The most important and basic thing that scientists should do to be educated in rhetoric is understand the modes of persuasion. These modes, as said in the quote, are ethos, logos, and pathos, which are the appeals to ethics, emotion, and logic, respectively. These modes of persuasion will help them persuade people of their findings and convince them that they are reliable and dependable. This is why it is important for scientists to be educated in the art of rhetoric. Thanks.